Hello everyone, I'm Farid Edrisi, researcher at the Department of Computer Science at Linnaeus University, and I'm here to present our paper with the title of Architectural Concerns for Digital Twin of the Organization. Before starting to present the paper in details, I want to mention the motivational aspects that lead us to write this paper. As you know, enhancing the organization's sustainability against different type of change is one of the main goals of industry, which could be achieved by utilizing digital twins advantage. In this regard, in a joint work with Scania and virtual manufacturing, at this paper we have reported the first attempts made in architecting and developing a digital twin of organization and evolving it to accommodate the change that happened at the business level. Especially, we first investigate how to employ a DTO in an already in place manufacturing process and then evolve it by developing and integrating new features by incremental developing approach. Then we have pinpointed a set of concerns to be confronted with when architecting a DTO that is expected to evolve over time according to the organization's requirements. However, from the experience, it emerged that defining an architectural framework for facilitating DTO's development and evolution is essential. At the first, I would like to answer two main questions about the importance of employing the digital twin of an organization, especially in industrial applications and making architecture for digital twin of an organization. As you know, a digital twin of the organization allows for representing all elements and connections of an organizational system in virtual models. It could be an important advantage for stakeholders and managers because they will be able to achieve continuous assessment and optimization of the organization by simulating and analyzing different data. So, employing a well-defined digital twin can help organizations to develop, change, innovate, and consequently enhance the organization's sustainability. On the other hand, adoption of a digital twin in an organization is not straightforward, and there are many challenges and issues regarding incorporation of different technologies. These challenges often prevent organizations from deciding to move into and invest in digital twins and related technology. So, to address these concerns efficiently, exploitation of architectures at different level of abstractions bring numerous advantages in order to capture different aspects of the system under development. In our industrial case study, the organization is a supplier of articles in the automotive industry that manufactures a product line with a large number of variants with just-in-time production rule. However, in this paper, we only focus on one of the different activities, and it's the manufacturing of a specific part of the final product. For making the digital twin of this case study, as already mentioned, we try to adopt the incremental development approach that you can see the figure of it here. Incremental development approach is important for companies as they usually don't want to invest huge amounts of money and time and replace the current system in one shot. Rather, they prefer to proceed step by step and invest money and time only if the process goes well. Okay, now let's have a detailed look on the production line, which we have focused in our paper at the first iteration by using enterprise architecture to describe the organization and information architectures. The production line consists of two workstations, workstation A and workstation D. The workstation A manufactures the product by two machines working in parallel, and workstation D packages the products by WD1 and WD2. The organization stakeholders would like to digitalize this section of the plant to get information about the orders, lead time, resource utilization, and amount of work in progress in real time. They would also like to predict the near future of these three characteristics in real-world application. In this regard, this simulation that you can in this slide shows the digitalization of the production line based on the monitorable points. The model that developed using the discrete event system toolbox in MATLAB and Simulink environment shows the sequence of order arrival waiting in queue for WA and WD execution in WA and WD and in order delivery. However, in the real production line, there is an issue regarding the manufacturing by machines in WA, which they don't always manufacture the units correctly and sometimes have defects which need a subsequent rework before packaging. According to the incremental development approach in this iteration, we first need to develop the digital twin of workstation B. After that, we need to integrate it with the previous digital twin of organization by considering the new data acquisition points and sharing of human operators between WD and WB. This figure in this slide illustrates the resulting model of the integration, where highlighted areas represent the new parts that have been added to evolve the initial DTO. As the result, the evolved DTO has the ability to identify the faulty order and the number of defective articles at them by analyzing different sensors data. In addition, it's able to estimate the reworking time that's useful in calculating the lead time. And finally, due to existing two different workstations that needs manual working, digital twin of organization employs a policy for optimally allocate them to WB and WD. From the given information, it's clear that making an evolved DTO is challenging, as it requires consider many different dimensions. If I want to summarize them, I can say that the main issues emerge when the organization, business, and information architecture are misaligned. So, understanding the relationships between different resources, processes, and available data is difficult. On the other hand, both organization, business, and information architecture are not flexible and they are hard to evolve. Consequently, by introducing or changing resources, processes, data, all of the architectures need a rearrangement by introducing technical depths, and it leads to architecture erosion. And finally, DTO is not flexible and hard to evolve. Therefore, by happening any change into organization, business, or information architecture, the whole DTO requires to be rearranged, which this also will lead to architecture erosion. So to have a sustainable digitalization of all parts of the organization, in addition to fully aligning of organizational business and the information architecture, the DTO should also have the ability to accommodate the continuous and rapid change to organization, business, and information architectures. To overcome these problems, we need to define an architectural framework which provides principles and practices for jointly specifying, aligning, and evolving organization, business, information architectures, and DTO. This architectural framework should include, firstly, an architectural pattern describing architectural elements and connectors with constraints on how they can be combined, achieving flexibility. Secondly, a reference model decomposing functionality into elements and data between them that cooperatively satisfy the organization needs. And finally, a reference architecture mapping the reference model onto system elements and defining the data flows between them. We also expect that the defined architecture framework address the concerns about modularity, granularity, decomposition, or composition styles, and the evolution, including self, joint, and emergent evolution. Due to the limited time, I refer you to the paper for more information about these concepts. Okay, as conclusion for my presentation, I should say that in this paper we try to make and develop a digital twin of an organization and discuss our experience in this journey. Therefore, at the first, we detailed the development process, leveraging enterprise architecture to map the organizational business architectures, order, structure, and behavior, and information architecture or status into a DTO. Then, we highlighted various concerns might be confronted with when architecting a DTO, and finally, we discussed the need for an architectural framework enabling the specification, alignment, and evolution of organization business information architectures, and DTO. For future work, our planning is devising the appropriate architectural framework, including the three characteristics discussed in previous slides to address the mentioned concerns. Thank you so much for your time and attention to this presentation.